So this is a build demonstration for a super simple Science Olympiad airplane, similar to the Division B airplane for the 2023 rule set. So we have 1/8 inch, 1/16 inch sticks. Apply a little glue stick. I like the Uhu glue stick. Position this over the plan. Right on the line. There's the leading edge. Next we will attach the wing ribs. Same idea, a little bit of glue stick. And we will butt the ribs up against the leading edge. And the covering material, you can probably tell, is grocery store produce bag material. The materials for this airplane in total run about $4. Runs about $4. And the propellers, another $3. So this is an airplane build basically for $7. Right, get all the wing ribs attached. Nice and straight. So there are only 5 wing ribs to keep things simple. 2 at the dihedral brakes, 2 at the ends, and the center rib. All right, and you notice that I have only the leading edge down in the plan right now, leading edge of the wing. We'll attach the trailing edge after because that's simpler. All right, now I'm going to apply super glue at this point just to the end rib joints. 1 drop of super glue. Then I'm going to get the trailing edge. And again, the glue stick. Then I'm going to touch it up against each one of the ribs. And in doing that, I know because the ribs were pre-cut to exact size that I have a regular shaped wing. We will hold that part together for a second because I kind of fudged that a little bit. Hold these 2 parts together. And you could use kicker or glue accelerator if you want these to dry a little bit quicker. But we're just going to do things pretty simple here. Now I'm going to put drops of glue in the other rib to spire joints. Hold that together for about 10 seconds. And the center rib. Hold it for 10 seconds. And the dihedral brake rib. All right. All right, that's the wing. Pretty simple, huh? Then we'll do the stabilizer. Again with the glue stick. So I did take the time to get appropriate density wood for each part. And that would be factored into the price I mentioned, $4. if you buy from a source like Specialized Balsa Wood, you can specify the density of the wood that you're ordering. And if you specify medium density, you will get 8 to 12 pound per cubic foot wood, and that will easily build to the weight that you're shooting for, which for most Science Olympiad rule sets, it's been 8 grams has been the minimum weight. We'll probably come out at about a gram or so, a gram and a half underweight, which is handy because then you can use clay ballast and reposition it to change the center of gravity to change the trim of the airplane while you're testing it. Okay, glue stick, and then once again, when I butt this up against each of the ribs, I will have a regular and rectangular shape. All right, and then we will apply glue, and I will hold the parts together while I'm gluing them, and hold them for maybe 10 seconds. So the goal of building this airplane is to see if we can build it in less than an hour, which should be doable. I'll hold that for about 10 seconds. Glue my finger to the part. All right. And we're going to glue the fin onto the tail boom. And we will just position the tail boom and hold it in place with a little bit of tape. All right. Then fin parts. Oh, missed a step. I do want glue stick on just this part of the tail boom to stick it to the covering. And actually with that on there, I don't really need to use the tape, so easier yet. All right, then the leading edge of the fin, which is angled for fun. You don't really have to make an angled leading edge, but if that's what you want to do, you can. All right. And I have the vertical on the fin. So this video is courtesy of National Free Flight Society Education Committee. I didn't introduce myself, but my name is Brian Turnbull. I'm a member of the Education Committee for the National Free Flight Society. All right, got all those parts down. I will hold the joints together a little bit while we apply glue. And we'll give that about 15 seconds. So that's all the flying surfaces, and you can see that went pretty quick. So I have the grocery bag covering, you can see, taped to the plan, and underneath the grocery bag covering is a sheet of wax paper to protect the plan from the super glue. And then I will cut the parts apart just a little bit so that it's easier to trim the covering. Actually, I think maybe I'll just trim the covering with a blade as I pick the parts up. So we'll run the single edge blade all the way along the one edge of the wing. Hi. I'm downstairs making a video. That's somebody coming home. All right, so we have the one edge of the wing trimmed. I will do another edge of the wing. Lower the hand down a little bit. All right, pretty close to being done trimming the wing. Got a little raggediness there, which we will clean up after the fact. All right. So I'm going to move the stabilizer and the tail boom out of the way a little bit and get covering trimmed on the tip of the wing. All right, and I'll just clean up what I did on the leading edge there. Got a little bit off center. That's pretty good. Good. So there's your wing. We'll just get the stabilizer. Maybe I'll slide the cutting mat over here now. Cutting on the cutting mat's a little bit easier. You notice that I have the blade angled slightly. I'm feeling for whether I'm cutting covering or cutting wood. And if I feel something a little higher resistance, I know that I'm cutting wood. But you see I have the blade angled this way and this way, then it's less likely to dig into the wood. All right. This is a brand new blade too. That makes covering go a little bit easier. All right, we will spin things around. Get the other edge of the stabilizer. See the angle of the blade? It makes it less likely to accidentally bite into the wood. All right, there's the stabilizer, and the fin is attached to the tail boom. So we will make the cuts around the fin outline. All right. And I'll use a pair of scissors to snip this little end away. Right. So we have 3 covering surfaces, and I'm not sure of the time that it took, but I'm guessing 10 to 15 minutes tops. Next thing we're going to do, we'll just take a quick look to make sure everything came out pretty flat, and it did. Okay, everything came out pretty flat. Covering's not perfectly smooth, but that doesn't really matter. So we're going to set aside the wing, the stabilizer, and the tail boom. We're going to get the dihedral angle set on the wing. So borrowing an idea from Chuck Marcos, which actually this entire build is basically based on a Science Olympiad design from Chuck Marcos, I'm going to crush with the side of the razor blade, not the sharp part, partway through at the edge of the rib where the dihedral break goes. So just a little crush. All right, and then I'm going to crack those spots. All right, they're both cracked. So there's some wood hanging on there, which is going to help us have a little bit stronger joint. Then I have a 1 3/4 inch tall support, and we will support the center of the wing upside down like that. We'll put a little bit of weight on each outer wing rib, and then we're going to glue the dihedral joints. We can be a little bit messier with the glue here because this is a pretty rough joint, since we basically just crushed it to create the cut. We're going to give it a couple pretty decent sized drops of glue. All right. We'll make sure that that's wing is down on the, we will just put a little weight here to make sure that the wing is down on the support, so that we end up with a nice square wing. All right, next we're gonna create our fuselage, and we are going to attach the tail boom to the left side of the fuselage. There is no right and left until we start to put the hooks, the hook and the front bearing on, but we're going to create a 2.5 degree angle on this tail boom, which is 1/4 inch. So this would be a straight line using the graph paper. This would be 1/4 inch, which will be 2.5 degrees. All right, so I had a mark for this, but it's actually up where the wing is. So I'm just going to hold it in place while I attach the tail boom, hold the fuselage still, put down some pretty good blobs of glue because this joint can take a beating. So I put it down like 4 pretty good drops of glue. Then I'm going to hover this over the mark. I'm overlapping about 3/8 to 5/8 of an inch underneath my finger here. So 5/8 of an inch overlap. All right, I'm going to hold that for maybe 30 seconds. 30 seconds maybe. All right, make it nice and strong. All right, then we are going to attach the rear hook. This rear hook's a little bit of a fancy bend. we could probably come up with something simpler than that, but it's just going to be slipped onto the center of the fuselage like that, and also glued. So we're going to get a little glue on the top of the rear hook. Joints of wire to wood are not super strong, and this also is a joint that takes a beating. And since we selected materials that are going to bring the weight to well under 8 grams, we can afford to put a little extra glue on this joint, and that'll protect it from breaking off. So that's worthwhile. All right. Next, we're going to attach the nose bearing holder for the Icara propeller. So I'm going to use the 24 centimeter Icara propeller that's often used on Science Olympiad kits because it gives pretty good performance without really modifying it. So when I mount this, I'm going to attempt to get a little bit of a left angle. So the little tiny piece of wood that will hold this mount is 3/32 of an inch thick, and the wood of the fuselage is 1/8 of an inch thick. So I'm going to angle the 3/32 inch piece just the width of the 1/8 inch piece, which will give it about a degree or two of left thrust. So left thrust is handy because we're going to be turning the airplane to the left. So I'm just going to do this with my fingers, just feeling it. And I'm getting a slight left angle there. All right, and then the nose bearing holder will attach to that. Nose bearing holder has to be, if you put super glue in first, has to be slipped in rather quickly because the glue will start to bond to the nose bearing, and then it can be difficult to attach. So we're going to put a little bit of glue there, a little bit of glue there, a little bit of glue there, and then we're going to position it and slip it in place quickly. So there's the Icara nose bearing holder. Do a little bit of repositioning there. Add just a little bit more glue. All right, so now we have the completed fuselage. The last part that goes on the fuselage actually is the stabilizer is attached to the end of the tail boom. And we're not going to make any special attempt to tilt this, but we do know that we want to end up with the left tip of the stabilizer tilted slightly higher than the right tip for a left turn. So we'll put a little super glue here. So you notice I have the stabilizer upside down because the ribs, the wood ribs, are showing here. And we will make a pretty good effort to line this up straight. All right. We'll hold that tail boom up against the joint a little bit. All right, so now we have the stabilizer attached. We'll just take a look at it and see if we ended up with any tilt. Because the joint is not super duper and the wood is a little bit on the tail boom is medium grade, 8 to 9 pound, it's not that hard to reposition the stabilizer slightly to give yourself the turn that you want to. the stabilizer tilt that you want to. You can kind of force the joint a little bit and get a little bit of tilt. We'll work on that actually after we've got the wing finished. So the super glue has been drying on the wing dihedral joints. So we will get rid of the weights. Then didn't make marks on this, so we'll quickly make marks. This is the wing attachment mechanism, and it's going to allow for 5/8 of an inch for tape to tape the wing to the fuselage on the front and back. So this will now position our this is going to be the stick, the fuselage wing mount stick is going to just be positioned right along the center rib, like that. So I've got a little support underneath there, and then I'm going to apply super glue again. Make sure I get the correct side. I won't go too crazy with the glue because I want to be able to slightly reposition it after I slide it on there. Okay. This I'm going to do, make my very best effort to put on very straight. Pretty good. Okay. All right. So now we are about 10 minutes from being finished, maybe less. We are going to cut about 1.5 inches of this 1-inch wide painter's tape. Cut it lengthwise. Then the wing. I'm going to attach the rear mount first. So put a little tape on the side. Oh, and I didn't mark the length of the nose, so we'll do that really quick. And this, for this airplane, the nose length is going to be 2.5 inches. So we'll make a little mark there. All right. Then the wing is located at 2.5 inches. And the tape is folded over. Oops, I said I was going to do the rear first. That would be handy to do. All right, so we'll just flip it around. Okay. So I've got the wing at 2.5 inches from the nose. Wrap the tape around nice and tight. All right, and then to give a little bit, we gave about 2 degrees, 2.5 degrees of decollage angle to the tail boom. And we're going to create about 2 degrees for the wing by slipping a little piece of 1/8 inch wood there. Not sure if that's going to be necessary, but we will initially set it up that way, and we may be able to remove that shim or make it a little bit thinner. And we will wrap that nice and tight. All right. Then the propeller slips into the propeller mount, and it's done. So 30 minutes, pretty good. So that airplane, with some careful trimming, will fly over 2 minutes with correct rubber and the correct rubber winding procedure, which there are also videos on the internet to demonstrate. The wood densities are important. The fuselage is 12 inches of 1/8 by 1/4, and it is 16 pounds per cubic foot, so it's quite stiff, quite hard. The wing spars and ribs and tail boom are between 8 and 10 pounds per cubic foot. 12 pounds per cubic foot would be okay too. To keep those surfaces light, you don't really need them heavy. So the overall weight of this airplane, I think I'll pause. So we're back and we're weighing our airplane that we just built, our half-hour Science Olympiad flight airplane. And let's see if we can position this so that you can see the scale. I think you can see that, 6.88 grams. 6.88 grams, so that's pretty good. That'll be very competitive. You can put the 1.12 grams of ballast on the airplane to alter the center of gravity, and you also can tape the wing on in different locations to also change the center of gravity and fine-tune the performance. Probably the best rubber band to use with this would be something in the 3/32 inch wide range. That's how you'd buy it. It's actually what you're looking for is something about 0.058 to 0.064 grams per inch. So once again, this is from the National Free Flight Society Education Committee in cooperation with Science Olympiad National to show you a really simple airplane that will perform really well for a team that is just starting in this event. Thanks very much.